Okay, Chapter 5 Study Guide. So let's start with this. This is what we did last week. Identify whether the following equations are linear. So, dead giveaway here, number 1, this is not going to be linear. Why? Right here we have an exponent. So this right here would not be linear. So if you get these type of problems, just put not linear. And it's because of the exponent there. So number 2 is linear, no exponents. This equation is actually written in a special kind of form that we're going to talk about next week, slope-intercept form. So this is linear, no exponents. Yes, it is. With these type of questions, you don't need to do much more. All you're doing is identifying whether it's linear or not. And number 3, I hope you could already identify that this is not going to be linear because of that exponent there. So all you would have to do is put not linear on your test. Not linear, and that is it. Okay. So number 4, the type of problem that we did last week, where this is before we learned about intercepts. And I'm going to want you to create a table for these type of problems. So first, you're going to identify whether the following equations are linear, and if they are linear, you're going to graph using a table. And notice it says table there, and not using intercepts. So number 4. We're going to graph this using a table like we did last week. So just create your table, and remember you could plug in any 3 points for x that you want. Okay, so I'll go ahead and plug -2, 0, and 2 in for x. Well, if you plug in -2 for x, right? Anywhere you see an x, you're going to plug in a 2, so that would be 2 times -2 plus y equals 4. 2 times -2 is -4. Right? How do you get rid of that -4? You add 4 on both sides. And if you do that, you get y equals 8. Okay? What about at x equals 0? That would be 2 times 0 plus y equals 4. Well, 2 times 0 is just 0. So y would equal 4. And last but not least, what about at 2? Well, that would be 2 times 2 plus y equals 4. Well, 2 times 2 is 4. And then we subtract 4 on both sides. So notice that we did get our x and y intercept, right? If you notice, this right here is our y-intercept, right? 0, 4, the x is 0. Whenever your x is 0, you have a y-intercept. And this right here is my x-intercept. Y is 0, right? So whenever your y is 0, you have an x-intercept. So we did get our intercepts, but I showed it on a table. So with these type of problems, I'm expecting you to show it on a table like we did last week. And then once you have your points there, you're going to plot them. So the first one's -2, 8, which would be all the way up here. Then we have 0, 4, which is going to be right here. And then we have 2, 0, which is going to be right here. And notice that this is a line. So use a ruler if you have one. Try to make it as neat as possible. But remember to connect those points with the line. That's all you would have to do for number 4. Number 5, exponent. Get one like number 5, then you're on easy street because you're not going to have to graph this. All you would have to do is just put not linear, because the directions clearly stated that you're only graphing if it is linear. Right? If it's not linear, you just need to put not linear. Find the x and y intercepts of the following linear equations. So, x-intercept, y-intercept. Try to do this on your own first, then unpause the video and see if you got it correct. But remember, for x-intercept, y has to equal 0. In order for us to cross the x-axis, y has to be 0. So anywhere you see a y, you're going to plug in a 0. So it would be 0 equals -1/4 x plus 1. And you solve this equation. Your first step is going to be to subtract 1 on both sides. We get -1 equals -1/4 x. And remember, how do we get rid of a fraction? We multiply by the reciprocal. What's the reciprocal of -1/4? Be -4/1, or just -4. right? Negative 4 times negative 1 would be a positive 4. Negative and a negative gives you a positive. And these would obviously cancel out. So what is your x-intercept? It would be 4, 0. How do we find our y-intercept? Well, for y-intercept, x has to be 0. Right? So anywhere we see an x, we're going to plug in a 0. So this would be y equals negative 1/4 times 0 plus 1. Well, negative 1/4 times 0 is 0, right? That's just going to disappear. And we're left with y equals 1. So what is our y-intercept? 0, 1. That's all you would need to do for that problem. They're not asking you to graph it. Number 7, fraction again, x-intercept. Anywhere you see an x, and plug in x-intercept, y has to equal 0. So anywhere you see a y, you're going to plug in a 0. So that's 0 equals 3/2 times x minus 9. You get rid of that minus 9 first. Remember, you always get rid of addition or subtraction first. And how do you do that? You add 9 on both sides. You get 9 equals 3/2 times x. How do you get rid of a fraction? You multiply by the reciprocal. And if you multiply this by 2/3, you would get x equals 6. So what would your x-intercept be? 6, 0. Y-intercept. For y-intercept, what has to equal 0? X has to equal 0. So anywhere you see an x, you're going to plug in a 0. So that's going to be y equals 3/2 times 0 minus 9. And that would be y equals negative 9, because this would just be 0. All right, so what would that be as an ordered pair? 0, negative 9. And next week we're going to talk a little bit more about equations that are in this form. We call this slope-intercept form. And there's actually an easier way to graph these type of equations rather than get your x and y-intercept. So number 8 is also in what we call slope-intercept form. We'll talk more about that next week. But that should be interesting, and it'll make those even easier to graph. But right now we're still using intercepts. So number 8, x-intercept, y-intercept. Actually, let's just do the x-intercept first before I write y-intercept. For x-intercept, y has to equal 0. So anywhere you see a y, you're going to plug in a 0. So that's 0 equals negative 2x plus 6. Subtract 6. Negative 6 equals negative 2x. And then you divide by negative 2. And right there you get your x-intercept, which is 3, 0. For y-intercept, what has to equal 0? X has to equal 0. So anywhere you see an x, you just plug in a 0. So negative 2 times 0 is nothing. So that'll just disappear. Y equals 6. So it would be 0, 6. That would be your y-intercept. And number 9, this is in standard form. So remember standard form from last week, ax plus by equals c. Remember that formula for tomorrow's test. Ax plus by equals c. So this is in standard form. Next week we'll work even more on standard form when we get to chapter 6, or module 6, I'm sorry. So if an equation's in standard form, that means it's automatically linear. Plus, if it doesn't have exponents, it's also going to be linear. How would we find the x and y-intercept for this? Well, for x-intercept, anywhere we see an x, for x-intercept, anywhere we see a y, we just have to put in a 0. So that would be negative x plus 0 equals negative 5. Now be careful. Yeah, this 0 here is going to disappear, right? But is the x by itself yet? No, we still have that negative attached to the x that we want to get rid of. So how do we get rid of that? We could either just multiply or divide by a negative 1. And that would cancel out the negatives there. And you'd be left with x equals 5, or 5, comma 0. That would be your x-intercept. What about your y-intercept? Well, for y-intercept, x has to equal 0. So anywhere you see an x, you place a 0. That'd be negative 0, which is just 0 plus y equals negative 5. Well, this again is just going to disappear, so it's just going to be y equals negative 5. So that would be 0, comma negative 5. All right? So for number 10 and 11, you're doing the same thing as before, except now you're going to graph them at the end, right? That's the only difference. So number 10 is 2/3 times y equals 2 minus 1/2 x. So you're first going to find your intercepts. How do you find your x-intercept? Y has to equal 0. Anywhere you see a y, you're going to plug in a 0. So that's going to be 2/3, and then instead of y, we'll have times 0. And that equals 2 minus 1/2 x. Well, 2/3 times 0 is going to turn into 0, so that gets rid of that. So we're going to be left with 0 equals 2 minus 1/2 x. All right, so this is 1/2 times x, right? Negative 1/2 times x. And then we have this 2 here, so we're first going to get rid of this positive 2. How do you get rid of a positive 2? With a negative 2. Subtract 2 on both sides there. So 0 minus 2 would be negative 2. And this will cancel out. And that negative needs to come down with the fraction. It's part of the fraction, so make sure you bring that down with the fraction, and it's negative 1/2 x. Now, remember, you need to multiply by the reciprocal in order to get rid of a fraction. The reciprocal of negative 1/2 would be negative 2 over 1, or just negative 2. And if you multiply both sides by negative 2, you get 4 for your x-intercept, or as an ordered pair, that would be 4, comma 0. What about your y-intercept? So for your y-intercept, x has to equal 0. So anywhere you see an x, you're going to plug in a 0. We have 2/3 y equals 2 minus 1/2 times 0. Well, negative 1/2 times 0, that's just going to be 0. So we're left with 2/3 y equals 2. Y isn't by itself yet. We need to get rid of that fraction that's right next to y. How do we get rid of a fraction? We multiply by the reciprocal, which would be, in this case, 3 over 2. And if you do that, you'd get your answer, which is y. This will cancel out, obviously. Y equals 3. So what would that be as an ordered pair? It would be 0, comma 3. Now, the only difference with these problems is that you're actually graphing it. So your first intercept was 4, 0, and that's your x-intercept. That's right here. And then we have 0, 3, which is right here. Just connect these with the line, and you are finished. Number 11, x-intercept. Let's do that first. So for x-intercept, that's not going to be enough room for me. So for x-intercept, your y has to equal 0. So anywhere you see a y, you're going to plug in 0. So that would be 18 times 0 equals 12x plus. That's not enough room for me. Let me erase this. Equals 12 x plus 108. All right, so 18 times 0 is 0, right? So it's just going to be 0 equals 12x plus 108. First thing you do is subtract by 108, right? And you get negative 108 equals 12x. How do you get rid of the 12? You divide by 12 on both sides, and that would give you your answer, which is x equals negative 9. Or as an ordered pair, that would be negative 9, comma 0. I don't have enough room to do the y-intercept on that side, so let me go ahead and, do it on this side. So for your y-intercept, x has to equal 0. So anywhere you see an x, you're going to plug in a 0. So that would be 18y equals 12 times 0 plus 108. Okay, 12 times 0 is 0, so that would just be 18y equals 108. You'd have to divide by 18 on both sides. And if you do that, you get y equals, that should be 6. So your ordered pair would be 0, 6. Now, you just graph them. So your first one is negative 9, 0, which is not going to fit in this graph, is it? This graph only goes up to negative 8, 0. So negative 9, 0 would be somewhere right there in that arrow. Okay, and then you have 0, 6, which is right here. And you connect it, and that is your line. That's it. Identify and interpret the intercepts for each situation. Plot the points on the graph and connect the points with the line segment. So a dolphin is 42 feet underwater and ascends at a constant rate for 14 seconds until it reaches the surface. So where does this dolphin start? 42 feet underwater. So underline that, underwater. Remember, your starting point is normally going to be your y-intercept, right? So what is our y-intercept going to be? Well, because it says underwater, the integer that would represent 42 feet underwater would be negative 42. Our y-intercept would be negative 42, which, as an ordered pair, remember for y-intercept, x is 0. It would be 0, negative 42. That would be your y-intercept. And this right here represents our starting, where the dolphin the initial sea level of the dolphin, where he started off before he started ascending. That's what that intercept would mean. So it says he finally reaches the surface at 14 seconds, right? So he goes from negative 42 to 0 after 14 seconds. So if we're at 0 on our y, he's at the surface, which is 0, then that means y is 0, and it took 14 seconds to get there. That's your x-intercept, right? So remember, with your x-intercept, your y is always going to be 0. And what does this represent? This represents the amount of time it took the dolphin to finally reach the surface. So if you graph these 2 points, so 0, negative 42 would be somewhere around here, and then 14, 0 would be right here. And you just connect them, but you wouldn't put arrows for this problem. Try to make a better line than I did. All right. And the last problem, number 13, Connor is running a 10 kilometer. You could read all that. We're already this video is already kind of long, so let's just skip to the equation. Equation's right there. So basically, they want you to find the x and y intercept and interpret it. So you could already figure out that the y-intercept is going to be 10, right? Because that's our starting point, and our starting point is always going to be our y-intercept. It's 10 kilometers. So, but let's go ahead and find it anyway. So x-intercept, remember for x-intercept, y has to equal 0. So if this messes you up here, just change f of x to y. Remember, f of x means the same thing as y. You could just go ahead and change this to y equals 10 minus 1/4 x, if that f of x there messes you up. So if y equals 0, that would be 0 equals 10 minus 1/4 x. First thing you want to get rid of is that 10. So you subtract by 10 on both sides. And if you do that, you get negative 10 equals negative 1/4 x. Remember, the way you get rid of a fraction is by multiplying by the reciprocal. Negative 4 over 1, which would just be negative 4. And negative 10 times negative 4 is positive 40. So what would your x-intercept be? 40, 0. Now, y-intercept. For y-intercept, x has to equal 0. So anywhere you see an x, you'll be plugging in 0. So that's y equals 10 minus 1/4 times 0. Well, 1/4 times 0 is 0. That's just going to vanish. You're left with 1. Y equals 10. So what's your y-intercept? 0, 10. 0, 10, your y-intercept would be right here. All right, and then your x-intercept is 40, 0, which is right here. That is a horrible line. All right, so what do these represent? Well, your y-intercept is going to represent the starting point, where he started when he began the race, before any time elapsed. And then your x-intercept is going to be the amount of time it took him to get to 0 kilometers, the amount of time it took him to finish. That's how you would interpret those two. That's it. That's your study guide. Good luck on your tests. See you tomorrow.